Hello everyone, how are you all doing today? In this video, let's try to solve this complicated looking definite integral. Most students will try to do method of substitution when they initially see this integral. But method of substitution is going to fail badly over here because these trigonometric functions are inside of that square root function. So you cannot apply method of substitution because it's just not going to work. There is this property of definite integral that we are going to use. I'm not only going to show you how to use it, but I'll also show you when to exactly use that property. This is the only video on the entire YouTube that will actually tell you when to use that property of definite integral. The property says if you have integral 0 to a f of x dx, you can write it as 0 to a f of a minus x. So that means you can actually replace that x with a minus x and the value will still remain the same. Okay, so that's the property. Now let's see when do you use this property. You can use this property for the definite integrals which are of the type fx divided by fx plus or minus f of a minus x. That means one hint that you can see is the fx in the numerator and denominator should be same, and in addition or subtraction there should be f of a minus x. That's case number one. Case number two is you use it when there are definite integrals which are combination of algebraic and trigonometric functions. Okay, so in those two cases you can actually use that definite integral property and it will make your calculation simpler. Okay, if you notice carefully, this function here is of the form fx divided by fx plus f of a minus x, where fx is your square root of sine x, and if you notice carefully, the square root of cos x is nothing but f of a minus x. That means square root of sine pi by 2 minus x or 90 minus x is nothing but cos x. So this function is actually of this exact form, which is why we'll be able to use that property of definite integral. I'll write the property again. So the property says integral of 0 to a f of x dx is equal to integral of 0 to a f of a minus x dx. Okay, so let's actually apply that property here. So using that property, that integral I is going to become integral of 0 to pi by 2. You can just replace your x in the integral with pi by 2 minus x. Okay, so you have square root of sine pi by 2 minus x divided by square root of sine pi by 2 minus x, okay, plus square root of cos pi by 2 minus x with respect to x. So now we know that sine of pi by 2 minus x is nothing but cos x, and cos of pi by 2 minus x is nothing but sine x. So let's do those replacements and let's see what do we have. So we have integral of 0 to pi by 2 square root of cos x divided by square root of this will also become cos x plus square root of, and this will become cos pi by 2 minus x is nothing but sin x. Now if you notice carefully, the integral that we have generated over here and the original integral that we had, the only difference between that is instead of this square root of sin x, now I have square root of cos x, and this is still integral I. So that means the denominators are still the same. So what we can do is we can actually add those equations up. So if this was your equation number 1, let's say, and if this was your equation number 2, so we can actually add those two equations. Okay, so we have, so if you add left hand side, you have I plus I is equal to, and you can add both of those integrals. So you have integral of 0 to pi by 2 square root of sin x divided by square root of sin x plus square root of cos x plus integral of 0 to pi by 2. Now we have square root of cos x divided by square root of cos x plus square root of sin x. Okay, obviously don't forget dx, which means with respect to x. Now since the limits of these integrals are same, you can actually just write a single integral and combine those functions. So you have 0 to pi by 2. So you can just write a single integral, and inside of that bracket you can write square root of sin x divided by square root of sin x plus square root of cos x plus square root of cos x divided by square root of cos x plus square root of sin x, and whole thing is getting integrated with respect to x. Okay, on the left hand side, I plus I, we have 2 times I. Now you can actually easily simplify it because the denominators are same. You can simply add those numerators. So we have integral of 0 to pi by 2. The denominator is simply square root of sine x plus square root of cos x, and the numerators will get added up. So square root of sine x plus square root of cos x, because the denominators were same. You could add those numerators up. Okay, and if you notice, this and this is exactly same and it will get cancelled. So essentially you have 2 times I is equal to integral of 0 to pi by 2 1 with respect to x. How simply you are able to cancel that function using that property. Okay, now we know integral of 1 is nothing but x. Okay, and we have those limits, so we have limits are 0 to pi by 2. Okay, now you can just do upper limit minus of the lower limit, so you have pi by 2 minus 0. And remember that this is not your final integral, this is your 2i. So you have 2i is equal to pi by 2. And if 2i is equal to pi by 2, therefore we can just divide by 2 here and say I is equal to pi by 4. And this is nothing but the final result of your definite integral that we were looking to solve. If you want to see more such helpful and conceptual math and calculus videos, don't forget to hit that subscribe button. I do post math and calculus content every single day. If you want to master calculus, hit that subscribe button. I'll see you tomorrow.